So our story started with a problem definition. We were tasked with transporting a load an exact distance with one main twist, must be powered by wind. We earned points by moving the most amount of weight in the least amount of time. Of course, there were constraints. Our vehicle needed to be less than a meter cubed, and so we started our design process by trading some designs we thought of ourselves, no matter how stupid they were. We looked at some various options, such as utilizing potential gravitational energy and a rolling object, or even a propeller to drive the back wheels of a vehicle. Our favorite option was the simplest option, and that was to make a sail to pull the vehicle forward. Before we started sketching anything, we dug into some research. We looked at how rolling resistance works, and this helped us settle on a four-wheel design early on. Once we had four main designs, we used a weighted decision matrix to vote on which
Yeah, so we're gonna
design we
keep this
thought would work the
design and
best.
everybody like this one.
With the design in mind, we started on simulations to determine the material and dimensions for our drawings. This allowed us to reduce on weight and costs of our vehicle. For the frame, we opted to go with 3/4 inch and 1/2 inch dowels as they were the lightest and cheapest materials. We had decided to use a stainless steel mixing bowl, as printing a bowl out of PLA would be more costly and time consuming. As for the wheels, we looked for one that would provide the best weight distribution and the largest radius. During our building process, we actually reduced the size of our vehicle by a substantial amount. We found that we don't need a very big frame to maintain stability, and there was no point in keeping it around. Additionally, thanks to our team's amazing woodworking skills, we swapped out a couple screws for wood glue, ultimately reducing the weight and
Design.
embody carbon.
Yeah, so this design
We also spent some time looking at
is
other
number
people's
one as well.
vehicles to
This
draw
one here is
inspiration as to
cool.
what not to do. Originally, we placed magnets on the axles so that we can adjust the friction and, through testing, calibrate our vehicle to land in the target zone. To our surprise, our vehicle actually worked the first time we tested it. All we had to do was hold the leaf blower in place and keep it at the max power. At this point, we were super confident, and all we had to do was just show up and win. We failed. We were so wrong. Someone obviously adjusted the entire foundation of the Hardy Lab and rigged the entire system. Because if you look in the first video, we kept the variables the exact same. And so even though our vehicle still functioned in the sense that it moved the mass across a distance within a short amount of time, it did not reach the right place, and we lost half our points as a result.